All right, we're now on lesson 4.4, and we want to do two things in this lesson, and I think this is going to be a review. We want to do what is known as evaluate polynomial functions. So given a particular input, can we come up with the output? And that'll be the first part of the lesson. And then we're going to talk again. I think we talked briefly about how we can look at functions, and there's certain pieces of information about the function that will tell us the general shape of the graph of a polynomial function, and we'll talk again about those in the second part of the lesson. So the first thing is some of your problems, and I've identified them here. If you're given these functions, can we come up with these outputs? This is known as evaluating a function for a particular given input value. And the thing that makes this a little bit different, typically we're inputting just a regular number. And these are a little more challenging because we're inputting these expressions, these monomials. So this says to go to the C function that's provided, and wherever you see x, you're going to input y cubed, and then you're going to simplify. Okay, so it looks like this. So in place of x, I'm going to put y cubed. Notice there's already a third power there. Minus 5, y cubed squared, and then plus 2. So literally we've done so far what we've been asked to do. Replace the x in the function with y cubed. And now we're going to simplify, remembering our exponent rules. We always do powers before we multiply. So let's just see if we can do two things at once. In this y cubed raised to the third power, this would make y to the ninth. That's that power raised to a power rule. You multiply the powers together. And now we can multiply by 4. And that makes 4y to the ninth. Raising y to the third to the second power makes y to the sixth. So this second term is going to be minus 5y to the sixth. And then we just bring down the constant plus 2. And so this is our answer for example letter A. Okay, any questions so far? All right, letter B says, technically it says, let's input 2a into the D function, and then whatever that result is, we'll multiply by 5. Okay, so let's first of all find out what D of 2a is. Using that same procedure that we looked at in example A, we're going to replace the 2x's with 2a in the D function. So it looks like 3 times 2a squared plus 6 times 2a minus 10. We do powers before we multiply, so the monomial 2a raised to the second is 4a squared times 3 is 12a squared. And then here we have plus 12a minus 10. And that takes care of this part. We just did the D of 2a, and now whatever that result is, we just multiply by 5. Each of these terms multiplied by 5. So you can essentially think of it like this, distributing 5 to each of the terms. 60a squared plus 60a minus 50. Any questions on example 1b? Okay, let's try letter C. This time we're going to go back to the D function, and in place of x, we're going to put y squared minus 1. So it looks like this. I've replaced the x's. Now we're going to do this. We're in the D function. Okay, so remember we do powers first before we multiply. So remember squaring a binomial, there's a three-step mental math process. You would square the first term. I'm just going to bring down this 3 for a second. If I square y squared, I get y to the 4th. And if you don't want to have to write y squared minus 1 down twice and use FOIL, you can do this little three-step process. Square the first term, and then inside the parentheses we have two terms, multiply them together, and then double that, or times 2. So y squared times negative 1 is negative y squared, but when I multiply that by 2, I get negative 2 y squared. So the process goes like this. Square the first term, first times second times 2, that'll give you the middle term, and then square the last term. And we'll come back to that. Okay, now I've set it up to distribute in both of these cases. So I'm going to distribute the 3. And here I'm going to distribute the 6. Bring down the minus 10. And now we're ready to combine like terms. This is a quartic term, y to the 4th, and I don't have any others. I'll just come over here and see if I can, I'll just come up here and we'll squeeze the answer in. So I got one quartic term. The y squares cancel, negative 6 plus 6, and that leaves me with all constants. 3 minus 6 is negative 3, minus 10 is negative 13. Yeah, if it's really a shortcut for doing this. Maybe doing this, because it says to just square it, multiply by itself. But if you don't want to write this down twice and use FOIL, you can always square the first term, which that's y to the 4th. The middle one is the tricky one. Just think, multiply these together, and then double that result, or times 2. And if you think about it, that's what would happen if we did the outer and the inner parts of FOIL. Outer and inner would just combine, and then you always square the last term. If you don't like that, or if that's just something you don't want to have to remember, you can always write it down twice and use FOIL. You could also use Pascal's triangle, I guess, if you like. No? Okay. Thought I'd give it a shot. Does that help you? That makes sense? Okay. I want you to try letter D on your own, and then we'll come back and see what you got. A little challenge. Okay, so you see there in blue the answer for example 1D. And let's move on to, I don't think we're going to need to do both of these. Some of this we haven't talked about, but it's a pretty simple concept. Let's just take letter A, and we've already described end behavior in previous lessons. This means we want to know the ends mean where is this function traveling, where is it going as I travel along the positive x-axis, and then where is it going on the left end or as I travel along the negative x-axis. So the way we write end behavior, in case you forgot, the way I describe the right side or the right end is as x approaches positive infinity. Okay, I'm traveling to the right, in other words. The function, known here as f of x, since it's going up, is also going to positive infinity. So to put this in just regular words, as I go to the right, the function is going up. And now don't forget, you also need to describe the left end. As I go to the left, Okay, so now I'm describing the left end. So as I move to the left, that's what this is saying. Now the function is going down, or in other words, it's approaching negative infinity. So as I move to the right, the function is going up. As I move to the left, the function is going down. Okay, that will be my answer for part A. On part B, we haven't really talked about odd degree or even degree, but that's a pretty simple concept. Just think this. If the right side and the left side are going in opposite directions, and that's what's happening here, right side's going up, left side's going down, just think opposite, odd. Okay, so letter B, this is going to be an odd degree function. If the right side and the left side are moving opposite directions, it's got to be odd. Letter B, you can see that they're going in the same direction. They're both going down, so this would be an even degree function. And then the number of real zeros, that means how many times or how many x-intercepts do we have? And you don't have to say, obviously we can't tell exactly where they are, we just need to say how many. So my answer for part C would be 3. My answer for part B, example B would be there are no real zeros. This has no x-intercepts. Okay, so any questions? I know I kind of flew through that. Okay, so when we get to this third example, we're trying to determine end behavior from a function instead of looking at a graph. So let me give you some, it's really pretty simple tips on how you can determine what the end behavior of a function is just by looking at the function and not having to rely on the graph of the function. So, two things. The first thing you should always observe is what is the lead coefficient. In particular, is it positive or negative? Alright, so make sure first of all that you're looking at a function in standard form, meaning that the highest exponent for x is in the lead, and then it should the function exponents should just count down in consecutive order until you get down to the constant. So this letter A, this function is in proper form. The lead coefficient is positive 5. So we can summarize end behavior like this. I'll just give you some general principles and then we'll apply to this particular problem. If the lead coefficient is positive, then the function has to go up on the right. And once I'm finished with this, we'll actually use end behavior language to answer the question. All right. And then to know what happens on the left, you look at the degree. And for this function, it's degree 5. If you're wondering what is the degree of a function, just look at the largest exponent for x. And in this case, we have an odd number degree. So if the degree is odd, the left will be opposite of the right. Opposite of right. Okay, so now that we've established, and obviously the counter example would apply. If the lead coefficient is negative, then the function is going to go down on the right. And then if the degree is even, instead of them being opposite, they'll be the same. Okay, so let's just go ahead now and use end behavior language to give our answer for letter A. So I'll start with describing the right end as x approaches positive infinity. Notice we've already established that the lead coefficient is positive, so in this case it's going to go up on the right. So that means f of x is approaching positive infinity. And then to do the left side, as x approaches negative infinity, we've already established that the degree is odd. Then the opposite will be happening on the left side. So it went up on the right. The function in this case is going to go down on the left. Okay, so for odd degree, they will go in opposite directions. And we saw that actually over here. We said that when the right and the left ends go in opposite directions, that has to be an odd function. Okay, so that's my answer for letter A. And now let's take a look at letter B. Now, letter B can be a little tricky. Don't just jump right in. Make sure that your terms are arranged properly first. And the highest exponent for x is going to be x to the 4th. So I'm just going to rearrange this real quickly so I can get the true picture of what's going on. Okay, so I notice, first of all, pay attention to the lead coefficient. That will tell you what happens on the right. And since this lead coefficient is negative, it's going to go down on the right. And the way we say that in end behavior language is as x approaches positive infinity, the function is approaching negative infinity. Okay, so we've taken care of the right side. Well, what about the left? Well, an even degree, which is what this is, it's 4th degree, means that the left side will match the right side. So as x approaches negative infinity, the function is going to do the same thing that it did on the right. It's still going to negative infinity. Okay, so that's what you're going to do on these problems that I've given here on your assignment. You're just looking at the function, and without looking at the graph, can you determine end behavior? Okay, I just want to take a minute and give you some detail on this problem that we were looking at earlier. I gave you the answer to, but in case you missed it, here's how this works, this previous problem, example 1D. Think first of evaluating the C function using 2b as an input, and then that result will be multiplied by negative 3. All right, so here is C of 2b, inputting 2b in for x in the C function. All right, and so I've done that, and now I'm going to simplify. This makes 8b cubed, and 8 times 4 is 32b cubed. This makes 4b squared, and multiplying by 5 makes negative 20b squared. And then I'm going to bring down the plus 2. And now, I've done the C of 2b, and now I need to multiply by negative 3. So just think, distribute negative 3 to all three terms, and we get negative 96b cubed plus 60b squared minus 6. Okay, and I'll just draw a line, and over here we'll work on the D function. So this will be done first. Let's input 4b minus 3 in for x in the D function. 4b minus 3 squared plus 6 times 4b minus 3, and then minus 10. Square the binomial. And this is square the first term, 16b squared. First times second times 2, that would be negative 12b times 2, which is negative 24b. And then square the last term, that makes plus 9. And I think I'll just go ahead and distribute here. We'll come back and distribute here. 24b minus 18 minus 10. And multiplying by 3, 48b squared minus 72b plus 27. Just bring down these other terms, put these together, and combining like terms, I get 48b squared minus 48b minus 1, and now I need to do the distributing of 6. So 6 times this. Okay, so we're going to do 48 times 6, 288b squared, and then minus 288b minus 6. All right, and so now we take this trinomial and this trinomial, and we add them together. So combine like terms. Well, there's only one cubic term, negative 96b cubed. We have a couple of quadratic terms, so let's add 60 plus 288, and we get 348 positive b squared. There's only one linear term, negative 288b. And then negative 6 minus 6 is negative 12. Okay, and that was the answer we gave on the previous slide. I just wanted to provide some detail in case you missed it and we didn't have time to go through this, so you can maybe retrace your steps and see what went wrong. I hope this helps. Let me know if you have any questions.